Hello, this is Mr. Harris, and this is the video on completing the square and solving quadratic functions. We need to learn how to complete the square so we can simplify and rewrite equations for conic sections, ellipses, parabolas, hyperbolic functions, and circles. Let's start off with a formalized definition of what completing the square is. Okay. The video, there we go. Okay, so that's what completing the square is. There you have at it. I'm going to go through a better way, but sometimes it's nice just to have an obvious definition. So before we begin this, let's just make sure everyone's good with quadratic equations. Quadratic equations are of that form. A is the coefficient of x squared, B is the coefficient of x, and C is the constant term. They're always set equal to 0. There's 4 ways to solve: factoring, using the quadratic equation, completing the square, and graphing. Let's look at the factoring method to solve a quadratic equation, quadratic function, what have you. And again, look like little horseshoes, all that good stuff. So factoring, again, there's a relationship between this term and this term, where there's 2 numbers. When we multiply them, we get that. And when we add them, we get that. We have this. Set each factor. This is one factor. This is another factor. Set each factor equal to 0. So that's where we get x equals -3 and x equals -5. 2 solutions. If I were to sketch some sort of quick, simple graph, the solutions are where it crosses the x-axis. The solutions are the roots. They are the x-intercepts. Let's try now the quadratic equation. This is the quadratic equation. You can write it in this format or this format. Sometimes this is helpful as well to remind you it's this term plus or minus this term. If you have trouble remembering your quadratic equation, remember there's always a song. Okay. So writing a quadratic equation, I'm going to sing it, write it while singing it again. 2a hang low under negative b plus or minus square root b squared minus 4ac. If you practice your quadratics, you will learn it automatic. 2a hang low. 2a hang low under negative b plus or minus square root b squared minus 4ac. If you practice your quadratic, you will learn it automatic. 2a hang low, all that good stuff. Yeah. So if you ever forget, sing that song, help you remember. There's various other songs on the internet, do your search, all that stuff. So we're back to the same equation. I just rewrote it in the general format so we can see it in terms of the placement of the numbers. So A would be 1, B would be 8, C would be 15. Plug in the terms in the equation, simplify and solve. You get the same thing. X is equal to -3 and X is equal to -5. Okay. The third way is through completing the square. So in completing the square, the first step is, remember originally it was set equal to 0? Well, go ahead and set it equal to the constant term. Meaning, if this was the original equation we had, I'm going to, in this case, subtract the constant term from both sides. Then I'm literally going to augment this. I'm going to take this b, and it's going to be b, in this case, it's 8. 8 divided by 2 squared yields 4 squared. So I'm going to add this to both sides, because just like a seesaw, if we do something on one side of the equal sign, we need to do it on the other side of the equal sign. So I'm going to take this, divide it by 2, and square it. Hopefully this looks somewhat familiar. There's something going on with the quadratic equation. B divided by 2, we just have to square it. When we derive the quadratic equation later in this unit, you'll definitely see that connection. But it'll be 8 divided by 2 squared. I'm simplifying it to 4 squared. We add that to both sides. It'll be x squared plus 4 squared equals 1. How did that become 1? In this case, we can combine them. Negative 15 plus 4 squared, or negative 15 plus 16 yields me with the positive 1. I keep this as 4 squared because the number inside parentheses is what I'm going to use to write my perfect square binomial. X plus 4 squared equals 1. So we can write anything in terms of a perfect square. In this case, it makes it a lot easier to solve. I take the square root of both sides. So I get x plus 4 equals plus or minus square root of 1, which is just 1. Then I get x equals negative 4 plus or minus 1. And we still get x equals negative 3 and negative 5. The last method, graphing, I'm going to do on my calculator. That's the equation. That's the graph. We're going to work backwards from the factored form, or from the solutions, if you will. So I'm going to do second calc 0, left bound. My cursor, I'm going to move it to the left of one of the roots or x-intercepts. Left bound, right bound, move it slightly to the right. Guess, I'm just going to hit enter. So one of the zeros is x equals negative 5. That's a solution. If you wanted to factor that, it would be x plus 5 as a factor. Find the other 0. Somewhere to the left, somewhere to the right. Notice how these are sort of like your guide marks. And then the other solution is negative 3. 4 ways to solve a quadratic equation. Hooray. Okay. Talking a bit more about completing the square in terminology. Again, you have a general perfect square, x plus some number, some number, squared equals 0. Here's an example, x plus 3 squared equals 0. If I write that out, FOIL it out, x squared plus 3x plus 3x plus 9 equals 0. I get x squared plus 6x plus 9. So we know this equals that. Notice this is my B term, this is my C term. So let's talk about what's going on when we are completing the square. Essentially, looking at an obvious perfect square trinomial, C equals whatever this B term is divided by 2 squared. In this case, 9 equals 6 divided by 2 squared, 9 equals 9. So this completing the square, we can write any quadratic, no matter how odd it is, as a perfect square trinomial and solve it easily this way. It also helps with graphing it. Just reminding you why we call these quadratic equations. The degree is 2, it's x squared. The area of any two-dimensional object is squared, something times something, x times x. In this case, remember this method of factoring. If I bisected this box, the area of this box would be x squared. This would be 3, 3, or 3x, 3x, because this would be x times x is x squared, 3 times x, 3 times x, 3 times 3 is 9. So literally, this quadrilateral puts the quad in quadratic. That's why we call them quadratics. Thank you, Al-Khwarizmi. As you'll see in this unit, he's an Islamic mathematician. Sort of algebra is named after him. So again, area equals length times width. If length equals width, then generally area is x times x or x squared. That's why we call quadratic equations, quadratic functions. Okay, so now let's just begin practicing. We have this already, b divided by 2, and now we know why we're doing this. So it's essentially going to be x plus b divided by 2, if you will. But we've done with that already. And again, all of these, the PDFs are posted next to these videos on the Google Classroom. I'm going to leave the link to the video and each PDF. You do not have to print these, only if you want to just take notes. It's up to you. You do not have to turn this in as well. Let's move on to this practice problem, shall we? Find the value of all this stuff. At this point, it's easy. In my mind, I'm initially thinking b divided by 2 squared. This is what we have to add to both sides to turn this into a perfect square trinomial. And remember, we know this is what c is equal to as well. So it's going to be 12 divided by 2, or 6. Square the result, 6 squared equals 36. And then we just add this to both, well, in this case, it's not even an equation. I'm saying add it to both sides, but right now we just need c to get a perfect square trinomial. So we have x squared plus 12x plus 36. Voila, 6 times 6 is 36. 6 plus 6 is 12. So c equals 36. I'm just filling this guided notes in. Again, feel free to pause the video if you need, work it out on your own, and then check. X plus 6 squared, look at that. Hooray. Remember, these are numbered pages, so I'm going to go on to page 2. Your numbers are in the bottom right. Page 2. So this is practice. I'll work one out, and then I'll just write the answer for number 2. Okay. There's a negative sign here. You have to include the negative. If you want to do keep flip change, fine, but make sure b is negative 24. So it's going to be negative 24. I'm writing this off to the side just to remind, right? So in this case, negative 24 divided by 2 squared equals negative 12 squared. So c equals positive 144, because negative 12 times negative 12 is positive 144. The equation would be x squared minus 24x plus 144. If I factored it, it would be x minus 12 squared. That's the benefit of leaving it in terms of whatever this is squared, whatever's in parentheses. If it's a negative one, it's x minus that. If it's a positive one, it'll be x plus that. I'm going to just quietly write this out. Pause it, work it, check to see what your answer is. Okay. Okay. So now I'm going to work through another one step by step. And in this case, we're going to actually solve and get the solutions. We're going to send c over to the other side. X squared minus 10x equals negative 13. I'm going to do my b over 2 squared here. In this case, our b is negative 10. And I'm going to add negative 5 squared to both sides. And this is how we complete the square. And then we simplify. Factoring we get, and simplifying we get. Now to solve, we simply take the square root of both sides. Equals plus or minus square root of 12. Remember, anytime we take the square root, the solution is plus and minus that. And then we're left with x equals 5 plus square root 12, and 5 minus square root 12. You can even write your answer as x equals 5 plus or minus the square root of 12. Remember, if I'm factoring the square root of 12, that's square root of 4 times the square root of 3. So we get 2 square root of 3. So another solution could be 5 plus or minus 2 square root 3. If we wanted to go to our calculator and get the decimals, one answer would be, once we add and subtract and all of that out, one answer would be 8.46, and the other one would be 1.536. Okay. Okay, I'm going to work this one out now. Previously, what we dealt with thus far was when our a value was 1. When a is 1, there's nothing we really have to do, but when a is a number other than 1, we do have to do the same thing. What really happens is we divide each term by the coefficient of x squared. If this were 1, dividing everything by 1 wouldn't do anything. But what really happens here is, to turn a into 1, we literally divide everything by whatever a is if it's a number other than 1. So we are left with x squared minus 4x plus 9 equals 0, because 0 divided by 3 is 0. Now let's solve and send this over. X squared minus 4x equals negative 9. Now we're going to add or complete the square by adding b divided by 2 squared to both sides. If you notice from the quadratic equation, negative b over 2a, in this case, when a is 1, it doesn't make a difference. So you're already beginning to see how, in this case, we divided this b by the a. Because I almost said b divided by 2a. When a is 1, it doesn't make a difference. This b is already divided by, so you can already see when we're going to go ahead and derive the quadratic equation, how completing the square, and that's actually how the quadratic equation was derived. Al-Khwarizmi started by completing the square and just came up with an efficient equation. But we're going to be using this b, so it's going to be negative 4 divided by 2 squared, which is negative 2 squared. So that's what we're going to add to both sides. Negative 9 plus positive 4. Solving, we get x minus 2 equals plus or minus the square root of negative 5. And just the intermediate step, we know we have to pull that negative sign out of the square root and turn it into I. So x minus 2 equals plus or minus I square root 5. So we get x equals 2 plus or minus I times the square root of 5. This quadratic equation still has 2 solutions. They're imaginary solutions, but there's still 2 solutions. A quick sketch of this. Whatever it's looking like, it looks like it definitely doesn't hit the x-axis. So let's say it looked like this. We will get to graphing complex numbers later in the unit. It would actually be on this side because it's a positive 2. We go out positive 2 units over. The square root of 5 is some number between 2 and 3. So we go up whatever that number is, and we go down whatever that number is. And these are the 2 imaginary solutions. Of course, if you look through the whole unit, you will see that's towards, I think, the middle of the unit, but I might as well show you now. Um, Beyond that, that's the solution. I wouldn't take the square root of 5 and use that as a number. That's just the answer. 2 plus I square root 5 and 2 minus I square root 5. Remember, complex numbers always come in pairs because this plus and minus. I'm going to work number 3. You guys are good. You can pause if you need. I'm going to work this number 3 out for you, and number 4 will be placed as a quiz. I am trying to use the TEDx to give you minor little quizzes, 2 questions, multiple choice quizzes, just select the best answer. This one will be a quiz question. This one I will work out. Notice the 2. This is easy enough. I'm just going to tell you the answer. X is equal to 1 and X is equal to 7. If you need me to work this out in more detail, that's why I have tutorials. Come visit during a tutorial. I'll work this one out. This one will be your quiz question. On to the next page. The last page of this completing the square. Write a quadratic equation in vertex form. Another thing with completing a square, it makes it very easy to have a quadratic equation where I could simply look at the equation and know what the transformations are and know what the vertex is. So I'm going to start off by completing the square. In this case, b divided by 2 squared. In this case, it would be b over 2a. It's just that a is 1. So 2 times 1 is just 2. In this case, b is 14 over 2 squared. So we get 7 squared. So we have y plus 7 squared equals x squared plus 14x plus 7 squared plus 44. Continuing on, we have 49 equals x plus 7 squared. So in terms of completing the square, this is the perfect square trinomial, x plus 7 squared. This is that c. You could send c over, you cannot. It doesn't really matter. Ultimately, we get x plus 7 squared minus 5. I'm going to work this out another way, going the method I was going previously, just so you know it works out either way. If I had x squared plus 14x plus 44 equals 0, equals negative 44, plus 7 squared equals negative 44 plus 7 squared, we get x plus 7 squared equals negative 44 plus positive 49 does yield a positive 5. If we want to write it as an equation, we then bring in the y. We have x plus 7 squared minus 5 equals y. When it's set equal to 0, that's what we want when y is 0. But in this case, this is the actual equation, y equals x plus 7 squared minus 5. And the good thing is this gives you the vertex. I can look at this and know the vertex of the quadratic is at positive 7 or negative 7 comma negative 5. Why is that? Well, this is just like basic transformations. If we're inside the parentheses, we move to the left 7 units, and then the whole function is moved down 5 units. This is also called the vertex form of the equation. If I did a quick sketch, if this is the parent function of all quadratic equations, this moved to the left 7 units and down 5 units. So that's why we know that the vertex, negative 7 comma negative 5, And the vertex is either the minimum or the maximum of the quadratic equation. So using completing the square in vertex form, we can look and tell what this is. Remember, y equals, so you have to, it's not plus 7, it's to the left 7, so that's why we get -7, and then it's down 5. Working through number 5, and then 6 will be your second and final quiz question for completing the square. Number 6 will be. So working through number 5, we're going to have x squared minus 12x plus -12 over 2 squared equals -22 plus -12 over 2 squared. That's x squared minus 12x plus, that's -6 squared equals -22 plus -6 squared is 36. And 36 plus -22 is positive 14. I can write this as a perfect square trinomial because -6 squared is 36. 6 times 6, or -6 times -6 is positive 36. -6 plus -6 is -12. So I have x minus 6 squared equals 14. In the vertex form, it's going to be y equals x minus 6 squared. We will have to subtract this 14 from both sides. So we know the parent function was moved 6 units right and down 14 units. So we know the vertex is 6 units right and down 14 units. And that's what the vertex is. To do a quick sketch, 6 units right, down 14 units, it would be something like that. And that's 5. 6 will be a quiz question. That's it for this video on completing the square. Thank you and have a wonderful day.